A very common proverb says, "You can't manage what you can't measure." Although I don't completely agree with that statement, I have to say, measurements are quite interesting. But the thing is, I always wondered, where does our measurement system come from? Like, is it totally random? Did someone just look at a rock and say, well, this is 1 meter, great, have a nice day? Well, I'm gonna try to provide answers to those questions in today's masterclass. The SI system is just a measurement and unit system that is shared by almost all countries across the world. So it comes from SI, so Système International in French, and you'll know why it comes from French in just 1 second. Part 1, a bit of history. Everything starts in 18th century France, during the Age of Enlightenment. The Age of Enlightenment lasts for the most part of the 18th century and is characterized by reason. Thus, the advancement of science and the invention of metrology urged scientists to ask themselves, why isn't there one common unit system? Metrology being the science of weights and measures. Then, in 1789, King Louis XVI calls for the Estates General. The Estates General was an assembly that could be called by the King of France in order to survey the population on different issues. All three states of the realm were summoned for the first time in 175 years. The three estates are first the clergy, second the nobility, and finally the commoners. Although they're the third estate, that class actually represents 80% of the general population of France. At the assembly in 1789, every estate asks for a national and common measuring system. Members of the assembly actually recalled more than 800 measuring units being used at that time in France alone, so we can understand how that can be a problem. So, on the 8th of May 1790, the motion is adopted and French scientists have the mandate to name and define the new and unified unit system. Then, on the 7th of April 1795, the unit system is set. It consists of 3 units. First, the meter for length, second, the kilogram for mass, and finally, the second for time. Thus, the MKS system, or the metric system, was made. Then the metric system spreads like wildfire throughout Europe in the 19th century as the Industrial Revolution calls for a universal unit. Then, on the 20th of May 1875, 17 nations signed the Meter Convention, thus creating an international unit system directed by the French Bureau International des Poids et Mesures. Those international units are all based on the MKS system created by the French, as we just saw it earlier. Since the 1875 Meter Convention, general conferences on weights and measures, called CGPM, are held every few years. As of today, only Liberia, Myanmar, and the US haven't adopted the metric system as their official measuring unit. However, the NASA adopted the SI system in 2007. Part 2, from a mathematical standpoint. First, the metric system's prefixes are a great advantage in a mathematical perspective, because if you're looking at very small things or quite large things, you can just change from one size to another with quite a bit of ease. For instance, to go from 1 micrometer to 1 meter, you only have to multiply by 10 to the negative 6. Those letters all have a name and are just added before the unit. For instance, micrometer or gigameter or gigasecond, etc. Plus, you only need to add zeros or remove zeros in order to change from one prefix to another. In other unit systems, such as the imperial unit, it's quite different and not so easy. The imperial unit system is the British unit system that was officially in use from 1824 to 1965, but was invented during the Middle Ages and has Roman, Celtic, and Anglo-Saxon origins. Fun fact, in the 16th century, England wanted to define what a rod was. So they went to church and they asked the first 16 men that went out of the church to put their left foot forward so that they could just line up all the left feet and measure that length. And they defined the rod as that exact length, which now we say it's 16.5 feet. As you can guess, the imperial system has quite a bit of units. So just for length, for instance, they have inches, feet, rod, yards, just to name a few. And transitioning from one unit to another is quite hard. For instance, going from 1 inch to 1 foot is you need to multiply the number of inches by 0.083333. So it's not very easy and kind of odd. The metric system contains 7 units. You can see them right here. Then, all the other units of the SI system are derived from those units. For instance, the SI unit for speed are meters per second, so meters and second are both in the 7 original units. The SI system also has an advantage in terms of temperature. For instance, in Fahrenheit, which is not a SI unit, 32 degrees is the point at which water freezes. But it's still normal to see -1 or -2, but the problem is that in chemistry, where you do different mathematics with those numbers, the negative becomes very problematic. Part 3. The SI system's importance. Before getting into the importance of a universal metric system, I'm going to talk to you about NASA's 1999 Mars Climate Orbiter. In the end of the 90s, NASA wanted to explore Mars's atmosphere. So it planned to send a spaceship there in orbit. But what happened was a US team working on the project worked with imperial units, as the others worked with the metric system. Errors in conversion, or lack thereof, actually caused the spacecraft to be asked to go on the orbit 60 kilometers, hear that, below Mars's surface. Needless to say, the spaceship crashed. This story goes to show how important it is to have a common unit system in order to collaborate with scientists all over the world and improve in sciences and technologies. Now, I urge you to go grab a clock and a ruler because on next Wednesday, the 20th of May, we will be celebrating the World Metrology Day in honor of the signature of the Meter Convention and celebrating the international system of units. And now, you'll know why to celebrate.